factoring. So there are certain types of equations multiplied out of us. Some patterns helpful in factoring. Now with the first two of these that we're going to discuss, you can use the box and diamond or factoring algebraically with the grouping like we've been doing the last couple of sections. But it's going to be a little bit more challenging to do so, and sometimes with the difference of squares it doesn't work as well either because you get higher exponents here too. So in a difference of squares we follow this pattern. If the first term, we only have two terms, if the first term is a perfect square and the second term is a perfect square and we are subtracting the two, then they can be factored using this form, a plus b times a minus b. Perfect squares with the numbers, the first 15, these are all perfect squares because they have a perfect square root. So the square root of 9 is 3, square root of 49 is 7, square root of 100 is 10, so on and so forth. Things like x squared also have a perfect square root. So the square root of x squared gives us x, square root of x to the fourth gives us x squared, because x squared times x squared would give us x to the fourth, so on and so forth. So some examples of that, and I'll show you why they work in just a few minutes. If I have x squared minus 16, x squared is a perfect square, 16 is also a perfect square, so I set this up as x plus 4, x minus 4, according to the pattern that I was using, or that I just saw. I'll scooch that up just a little bit. So that one at the bottom of your screen. So the reason this works, and we'll put that as a check. This is our actual answer. That's all there is to it. To check it though, x plus 4 times x minus 4. We can FOIL or use the box to multiply. So x times x gives us x squared. X times negative 4 gives us negative 4x. 4 times x gives us positive 4x. And 4 times negative 4 gives us minus 16 or negative 16. So the reason that this pattern works is because when we multiply that out, these two terms, negative 4x and positive 4x, are only like terms in this expression. Those add out to 0. So what I'm left with is x squared minus 16. And that is why the difference of squares works. The order of them is important. Some people get thrown by a problem like this. 16 is a perfect square, 49x squared is also a perfect square, but because the minus is right here, it's important to keep it in this order. So the square root of 16 is 4, square root of 49x squared is 7x, so 4 plus 7x, 4 minus 7x. And if we multiply that out, that, once again, that's our answer. If we multiply that out, we have 16 minus 28x plus 28x minus 49x squared. So once again, those center terms add out and we're left with 16 minus 49x squared, which is what we started with. So that is difference of squares. Important things to note, it has to be minus, otherwise it doesn't work. The next one we're dealing with is called a perfect square trinomial. So this is when we take a plus b and we square that whole thing. Keep in mind that a plus b squared is a plus b times a plus b, not a squared plus b squared. We can't distribute that squared in there, that exponent, because of that plus. So if we multiplied that out, we'd have a times a, which is a squared, a times b, which is ab, b times a, which is also ab, or ba, doesn't matter which, and then b times b, which is b squared. Our only like terms here are ab and ab, and we have two of them, so this is a squared plus 2ab plus b squared. So if I take a look at my worksheet, about that. I'm looking at whether my first term, looking at number 8 at the worksheet, is my first term a perfect square, 9x squared, and it is. And is my last term a perfect square? 1 squared equals 1. So yes, they're both perfect square terms. So if I write this as the square root of 9x squared is 3x, because 3x times 3x gives me 3x times 3x. I don't know if I said plus there. Anyway, 3x times 3x gives us 9x squared, and 1 times 1 gives us 1. If that's a negative, and then you square it. Now here's why this works. Well, and you want to check. You always want to check on perfect square trinomials because of that center term. So if I have 3x minus 1 times 3x minus 1, 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Negative 1 times 3x is again negative 3x. And negative 1 times negative 1 is a positive 1. So 9x squared minus 6x plus 1. So we're good to go, and this is how we can write that out. That is our factored form of that trinomial. Something like this one, where we have both x's and y's, we still have to check again. Is our first term, 9x squared, a perfect square? And it is. 64y squared is also a perfect square. So if we take the square root of the first one, which is 3x, the square root of the last one, which is 8y, take our sign from the middle there and square it. Then we want to check our answer. Once again, always check your answer with a perfect square trinomial. So 3x plus 8y times 3x plus 8y. And again, you can use the box and diamond or the algebraic grouping to factor these. Just some of them, if you can see the pattern, it's going to be a lot quicker. And the difference of squares, once again, is trickier without it. So multiply out 3x squared plus 24xy plus 24xy plus 64y squared. And those two in the middle add up, so we've got 3x squared plus 48xy plus 64y squared. And that's it. The last one we're going to bring up, and we're not going to test on this, but I wanted to introduce it. It is in the Math 65 curriculum, but not the Common Core standards. The sum and the difference of two cubes. Now, these ones, if you're just barely holding on with perfect square trinomial and difference of squares, then I would just stop the video right here because I'm not going to test you on this. However, it's not a bad thing to learn. That should be a third, not squared. If I have the sum of two cubes or the difference of two cubes, this pattern arises, and it's a tough pattern to see. If I have a plus, then my first one is a plus b, and then my second one is minus, so the opposite sign there. Same thing with the difference, same sign here, opposite sign here. Now you kind of have to see this one in action. So if I look at this as two perfect cubes, so cubed is something times itself 3 times. So if I have 125x to the third, that is the same as 5x to the third. Plus, the cube root of 8 is 2 to the third. So in this situation where I'm looking at the sum of two cubes, my a value is 5x, my b value is 2. So if I factor this, write this factored out, I've got 5x plus 2 times 5x squared. Remember, it's got to be in parentheses, so that's going to be 25x squared minus 5x times 2 So 10x. And we're just going with the sign that is here. So that's what you got to watch out for. And then plus b squared, which is 4. Now, that's my factored form of that one when it's a cube. That one's pretty tricky, so you want to be careful with that. Inside, let's see, hang on. And I'm going to go ahead and leave it there for the sum and the difference of 2 cubes. Just so you've seen it, but it's definitely not one I'm going to test on. So that wraps up 7.4. We will have a mid-chapter test next class. So make sure you're prepared for that. Factoring trinomials and polynomials is basically what we're testing on. And that's it. Thank you.